Hello, good morning. Can you hear me?
Yes, sir. Good morning. We can hear you.
Okay. Can you see the board?
Yes, sir. But little upper part not seen.
Okay. So let me adjust. Okay, now can you see the upper part?
Sir, can you take the camera a bit backwards, sir?
Okay, now.
Yes, sir.
Okay. So audio is okay, video is okay, so we can start. So yesterday, what we were doing the RDRL magnetism, and what we had seen. Just to recapitulate a little bit from yesterday. Okay. So as to maintain the continuity. Okay, what we had done that when the ship is being newly built, then the ship is lying in the same direction for a considerable period of time. The arithmetic lines of forces are passing through the ship, inducing the magnetism in the structure of the ship, causing red and blue pole. Red means north and blue means south poles. Okay, and these red and blue poles in turn they create a magnetic field at the compass position. And because of this magnetic field created at the compass position, okay, the magnetic compass instead of pointing towards the north starts pointing in some other direction, and that is what we call a deviation. So the total field which is acting, or total permanent magnetic field which is acting at the compass position due to ship's magnetism, that we had divided into three components. One was the fore and aft horizontal component that we had called it force P, a athwartship horizontal component that we had called force Q, and vertical component we had called it as force R. Force P and Q are responsible for about 70% deviation what we see on the ship. So force P and force Q, there is a sign convention. Sign convention means just because somebody decided to call it this way, that is why that thing is continuing. So force P, if it is acting towards bow, it is considered positive. It is taken as positive. And force P, if it is acting towards stern, it is taken as negative. Force Q, if it is acting towards starboard, it is taken as positive. Force Q, if it is acting towards port, it is considered negative. Force R, which is a vertical component, if it is acting vertically downward, it is taken as positive. And if it is acting vertically upward, it is taken as negative. Okay. So depending on the heading on which the vessel was built, okay, the total force which is acting at the compass position, which we had shown by this letter F yesterday. Okay, just I'll just get the new black pen. Okay, so the force acting at the compass position, let us say it was acting in this direction. So this is 4.5 horizontal component, that is P. This is a third ship horizontal component, this is Q, and this is R. So this is the forward of the ship, this is aft of the ship. So as you can see, P here is positive, Q here is also positive, R here is also positive. P is acting towards bow, so it is positive. Q is acting towards the starboard, so it is also positive. And R is acting vertically up downwards, so it is also positive. But let us say if the total force acting at the compass position, okay, let us say this is forward and this is aft. So the total force, let us say, was acting in this direction. In that case, this is the 4.5 horizontal component, this is P, so it is positive. What about the third shape horizontal component? That will become like this, that is Q, so this will become negative. So it is acting towards port. And what about the vertical component, R? That will also be negative. So if the total force, total permanent magnetic field acting at the compass position is, let us say, in this direction, okay, in that case the force P is positive, force Q is negative, and force R is negative. Okay, so let us say if the total force was acting, let us say, in this direction, okay, so in this case this is the 4.5 horizontal component. Now it is coming towards aft, so P is, in this case, is negative. Okay, what about the third ship horizontal component that is going like this? Q is also negative. And what about the R? R is also negative because it is going vertically upward. So if the total force acting at the compass position, this is the compass position, is going in this direction, so then P is also negative, Q is also negative, and R is also negative. And the last one, what you can see is this. Oh, sorry, we can show like this. If the total force acting at the compass position is in this direction, then of course the 4.5 horizontal component will be acting towards aft, so P is negative. P is negative. A third ship horizontal component, that is Q, that is acting towards starboard, so it is positive. And vertical component is R. This is also positive. Okay, so any ship can have a plus P or minus P, could have a plus Q or minus Q, or it could have a plus R and minus R. Whether a ship will have plus P or minus P, whether a ship will have plus Q or minus Q, or whether a ship will have plus R or minus R, it will depend on what that we'll see later. So out of that, let us first consider this force P. So what is the force P? First P, yesterday we have written it, and anyway, it is the 4.5 horizontal component of ship's permanent magnetic field acting at compass position. So it is the 4.5 horizontal component of ship's permanent magnetic field acting at the compass position. So that there are only two possible directions of P. Either it is acting towards forward or it is acting towards aft. So if a ship is having force P acting towards forward, so it will remain so throughout the life of the vessel. If the vessel is having force P acting towards negative, okay, it will have force P acting towards negative throughout the life of the ship. Okay. Now, how this force P is causing deviation? Let us see that. So let us say, let us consider that we are on a ship where the force P is acting towards forward. That means we are on a ship where the value of P is positive. That means it is acting towards bow. Now let us say we are drawing the plan view of a ship. Let us say a ship is sailing in this direction. A ship is sailing in the northerly direction. The heading of the ship is towards north. So in this class, when we are talking about north, always we are talking about magnetic north. Okay, we are not talking about the geographical thing. Here everything is negative. So because we have the force P acting towards bow, so in which direction the force P is acting? So this is the compass position and force P is acting in this direction. Okay, which is the other force acting at the compass position? Let us forget about Q and R, but the other force which is acting at the compass position, which is trying to align the magnetic compass needle pointing towards north, is force H, correct? So what is the direction of H? If you remember from yesterday's lecture, what is the direction of H? Sorry, yeah, what is the direction of H?
North.
So H is also acting towards north. That means at the compass position, okay, then you have this force H is also acting towards north. Now, what is the angle in this case between H and P? So P is also yes. So at the compass position, okay, we have the P acting in this direction. At the compass position, we have the H also acting in the same direction. So is there an angle between H and P? No, zero. So will this force P deflect the magnetic compass? Answer is no, because both the forces are acting in the same direction. Okay, so let us say now put the vessel in the easterly heading. Vessel is sailing towards east. Now what happens? This force P is acting in this direction. Because force P is a force always acting towards bow. In which direction H is acting? H is a force always acting towards north. In this direction H is acting. So P is due to the ship's magnetism, H is due to the Earth's magnetism, which is trying to align the magnetic compass towards north. So what happens, because there is a force acting at compass position, okay, apart from H, what will happen? Let us say this is the resultant of H and P. Okay, so let us say this is the resultant of H and P. Okay. Now, if this force P was not there, your magnetic compass needle, okay, would have been pointing in this direction. But because this force P is present at the compass position, so now the needle will point in the direction of the resultant of H and P, correct?
Yes, sir.
अगर ये P नहीं होता तो needle would have been pointing in this direction. But because this P is there, the needle will point in this direction. That means the magnetic compass has been deflected from north by this much angle. So this is what you have is the deviation. This is what the deviation what you experience on the ship. Understand? And in this case, as you can see, the deviation will be easterly because the magnetic compass needle has been deflected towards the east. Is it clear?
Yes,
So
sir.
यहाँ पे deviation क्या होगा? यहाँ पे deviation is 0. And let us just give some value. Let us say deviation here is 9 degrees east. I'm just putting arbitrary value 9 degrees east. Now let us take a situation between 0 and 90. Let us take a situation here. Let us take a heading of 040. So when the heading is 040, force P is acting in this direction. Okay, same force P. Force P is not changing. Force P remains a constant force throughout the life of the vessel. It doesn't change in direction. also it doesn't change in magnitude. It is a constant force. So force you can say it is acting more or less in the northeast direction. So what we can do, we can have a easterly component of this force. This is the easterly component of this force. And what is this? This is the northerly component of this force. So this force we have now resolved into easterly component and northerly component. Because the force was acting in the northeast direction. Not exactly northeast, but in the northeast general direction. In which direction H is acting? H is also H is acting in the same direction. H is always acting towards north. So this component is now adding on to H, and this component, easterly component, will cause a deviation. So now a component of the P has been divided into two components. So one is this component, one is this component. This component is adding on to H, while this component as well is acting perpendicular to H and this component. So what will happen? And deviation will again occur, but this deviation will be less than or more than this 90 degrees. This will be less, correct? Because here only a component or a part of P is acting as a deflecting component. Here the entire force P is acting as a deflecting component. So obviously the deviation here will be less than the deviation here. Is it understood?
Yes, sir.
Let us say the deviation what you get here is 4 degrees east. So now you can understand that on different heading you will have different deviation. So if I say one diagram I draw here, and I draw one diagram here. So here let us say heading is 015, and here the heading is let us say 070. On which heading you will have more deviation due to force P?
070.
Obviously 070. So as we change the course from 0 to 90, can we say that deviation will continue to increase and will become maximum here?
Yes, sir.
Okay, so that is why on the shape, okay, we have different deviation on different headings. So that is why the deviation is changing with the ship heading. Remember, this force P is not changing. Okay, and for the same place, H is also not changing. H is changing with a change of place, but we are this when we are considering the change of course. This change of course we are doing for the same place. So H is also constant for the same place. P is definitely constant. Okay, but the even after being constant H and P, the amount of deviation what they will produce will be different on different headings, because as we are changing the force, okay, as we are changing the course, ship's course, the angle between H and P is changing. Because of that, the deviation is changing. Is this understood?
Yes, sir.
So now if you go on a westerly heading, what will happen? Force P is a force always acting towards bow, and force H is acting here. So now if I complete this resultant or parallelogram, this thing, so now your resultant is acting in this direction. So this is the deviation. In this case, your magnetic compass, if this force P was not there, would have been pointing in this direction. But because of this force P, it has been pointing in this direction. So this is the deviation. In this case, what you will have? Deviation will be westerly. So here the deviation is, let us say, 9 degrees west. So you could have easterly deviation or you could have westerly deviation due to force P. And this westerly deviation also will be different on different headings. So as we change the course, the amount of deviation will also change, and the sign of deviation also will change depending on which heading the vessel is going. That is why we observe different deviation on different headings. Is it understood? Any doubt?
No, sir.
Okay. Now the next thing is that whether a vessel will have plus P or minus P, or even if the vessel is having plus P and minus P, how much of the P will the vessel will have? This will depend on what? So what we are saying that whether a ship, merchant ship will have plus P or minus P, it will depend on what? And what will be the magnitude of this P? That will depend on what? So whether a vessel will have plus P or minus P, it will depend only and only and only on the heading in which the vessel was built. The heading in which the vessel was directed, the heading in which the vessel was standing for a long period of time, that is the heading which will determine whether a vessel will have plus P or vessel will have minus P. How? Let us see. So when we are talking about force P is a horizontal force. And what is force H? Force H is also horizontal force. The force H is the horizontal component of the Earth's magnetic field. And force P is 4.5 horizontal component of the ship's magnetic field. So can we say that horizontal component of the Earth's magnetism will induce the magnetism in the horizontal plane of the vessel? Horizontal component of the Earth's magnetism, that is H, which will induce the magnetism in the horizontal plane of the vessel.
Yes, sir.
And vertical component of the Earth's magnetism, that is Z, will induce the magnetism in the vertical plane of the vessel. So basically, what is the inducing force for force P to come out? It is the force H.
H.
So it is the force H, which is the horizontal component of the Earth's magnetic field, which is causing this force H. So let us see. Suppose a vessel is built. When the ship was being built, it was standing in the northerly direction for a long period of time. Ship was heading in this direction. When the ship was being built, so in which direction H is going? H is always going towards north. So that means the inducing force is entering from this side and exiting from this side. That means this ship will have blue pole towards aft. So this ship will have induced blue pole towards aft and will have a red pole towards forward. Blue means south, red means north. This I have already explained. So because the inducing force is entering from the aft side, so this will create a blue pole towards the aft of the vessel, and it is exiting from the forward side, so the forward part of the vessel will become red. Now what will happen? After this red and blue poles have been induced and they have become a permanent poles, then within the ship, the force will be acting from red to blue. So what I'm saying that H ने क्या create किया? H ने ये blue and red pole create किया. After that, now the ship is sailing with this permanent blue poles towards aft and permanent red pole towards forward. So now the new building has finished and ship is now sailing. It is having blue pole aft, red pole forward. So the force is acting always from the red pole to blue pole. So this vessel will have what? So a ship which is built in a northerly direction will always have minus P. Understood?
Yes, sir.
Similarly, let us say if the vessel was built in the southerly direction. That means the ship was standing in the southerly direction for a long period of time. Then in this case, what will happen? The H is going in this direction. H is always acting towards north. So the inducing field is entering from this side and exiting from this side. So in this case, you will have blue pole towards forward, that is the south pole, and you will have red poles towards aft. So this blue pole and red poles will become permanent poles, and now the ship is sailing. So in that case, now the force within the ship will be acting from red to blue. So the force within the ship is acting from red to blue. So this is what, this is a force acting towards forward. In this case, the vessel is having plus P. So a vessel which is built in the southerly direction will always have plus P. Vessel built in the northern direction will always have minus P. Is it understood?
Yes, sir.
Yes, sir.
Let us see now the vessel being built in the easterly direction. The ship is being built in the easterly direction. So in which direction H is going? H is always going in this direction. So now what will happen? Inducing field is entering from this side and exiting from this side. So obviously this will become blue and this will become red. The port side is now becoming blue. Sorry, starboard side is becoming blue and the port side is becoming red. So these blue poles and red poles will become permanent poles. What will happen? Now the force within the ship is acting from red to blue. That means this vessel will have plus Q. Because it is acting towards starboard, it will have plus Q. Okay. Similarly, if a vessel is being built in the westerly direction, okay, when the vessel is being built in the westerly direction, so in that case, the inducing force H is going from here. So now you'll have blue pole towards port side. Sorry, the blue pole you will have towards port side, and you will have a red pole towards starboard side. After this, red and blue poles have been created as a permanent poles, and now the ship comes into the active sailing. Now the within the ship, the force will be acting from this red to this blue. Okay, so that means now this force is acting towards port, so minus Q. Sorry, minus Q. So a vessel which is built in the easterly direction will always have plus Q. A vessel which is built in the westerly direction will always have minus Q. Is this much understood? Hello.
Yes, sir.
Now let us say a vessel which is built in the northeast quadrant. Take any heading 03040. Let us say a vessel is built in this quadrant. In which direction H is going? H is always going in this direction. So now we can see that there will be a blue pole on the starboard quarter of the vessel, and we'll have red pole towards the port forward. Because H is going in this direction, so induction here will be blue, induction here will be red. After the ship has come into active service and this blue and red poles have been created as a permanent poles, now the force within the ship is acting from this red to this. So this force, as you can see, it is neither pure easterly or not. In this case, as you can see, that this force which is acting from red to blue, okay, so it is acting in what direction?
Southeastern.
Okay, so now you can see it will have a component like this, and we'll have a component like this. Okay, hello. So this force can be resolved into fore and aft component and a thrust shape component. We are not talking about that north and south component. We are talking about, because plus P and plus Q and minus P and minus Q is with respect to whether they are acting towards bow or stern or acting towards starboard or port. So this force is acting towards south. That is no problem. But we have to resolve into fore and aft component and a thrust shape component. So fore and aft component will go towards aft, and a thrust shape component will go towards starboard. Is that correct?
Yes, sir.
इस फोर्स का कंपोनेंट ऐसे थोड़ी चला जाएगा. या sports का component ऐसे थोड़ी चला जाएगा. We have resolving. When you will do, this will be the resolving, ना. So in this case, what will happen? This vessel will have what? Minus P, and what will have plus P.
Positive Q.
Okay. So entirely in the northeast quadrant, whichever heading you see, the vessel will have minus P and plus P. कोई भी heading आप उठा के देख लो. As long as the vessel is built in the northeast quadrant, the vessel will have minus P and plus P. If you can see in this quadrant, that is in the southeast quadrant, the ship is built. So now H is going in this direction. So what we will have? We will have blue pole here towards the starboard bow, and we'll have a red pole towards the port quarter. Now the force after the vessel has come into active service, the vessel force is acting in which direction? This direction. So now if we resolve this into 4.5 component and a third ship component, the 4.5 component is going like this, and the third ship component is coming like this. So in this case, what the vessel will have? The vessel, this case, the vessel is having plus P, and vessel will have plus Q, right? Because 4.5 component is going towards bow, and the third ship component is coming towards starboard. So vessel is having Q. So a vessel which is built in the southeast quadrant will always have plus P and plus Q. Suppose a ship is built on a heading of 135, then that vessel will have plus P and plus Q. Is it understood?
Yes, sir.
Suppose now the ship is built in the southwesterly quadrant. So H is always inducing force is always acting towards north. So now what you'll have? We'll have blue pole created on the port bow, and we'll have red pole created at the starboard quarter. After the ship has come into active service, the force is going from red to blue. If I take the component 4.5 component and a third ship component, the 4.5 component is always going or obviously going towards bow, and a third ship component is now coming towards port. This vessel is having plus P and will have minus Q. So a vessel which is built in the southwesterly quadrant will always have plus P and minus Q. Last quadrant, vessel which is built in the northwesterly quadrant. So now I'm not going to show the direction of H. H is going in this direction. So obviously you will have blue pole here and a red pole created here. The port quarter is becoming blue and starboard bow is coming red. So now the force is going from red to blue. If I take the 4.5 component and a third ship component of this force, the 4.5 component obviously is going towards aft, and the third ship component is coming towards port. This vessel will have minus P, okay, and also have minus P. Is it clear? You can see here, this is minus P, and also minus P. So as long as the vessel's heading is northerly, northerly means it could be 000, it could be 040, or it could be 320. That vessel will have always have minus P. So if a vessel is built on any northerly heading, that vessel will always have minus P. You can see here minus Q. Sorry, this here you can see plus P, and plus P. The vessel which is built on southerly heading will always have plus P. The southerly heading could be 180, it could be 120, or it could be 230. That vessel will always have plus P. You can see here plus Q, and plus Q. The vessel which is built on any easterly heading will have plus Q. It could be 045, it could be 090, it could be 135. That vessel will have plus Q. And you can see here minus Q, and minus Q. The vessel which is built on the westerly heading will always have minus Q. It could be 270, it could be 315, or it could be 220. Is this clear? So whether a vessel will have plus P or minus Q, plus P or minus P, or vessel will have plus Q or minus Q, it will only and only and only depend on the heading on which the vessel was built, and not nothing on and not on anything else. Is it clear? So the question which can be asked is that a vessel was built in this heading. So what is the sign of plus P or plus Q you could have? Or they may also ask, connected to this question, that what kind of deviation they will produce. So that we will see later on, that plus P is causing what and plus Q is causing what. Okay. So is this understood? That polarity, that means the sign of plus P and minus P and plus Q and minus Q will depend only in the heading on which the vessel was built. Is it clear? Hello?
Yes, sir.
Any doubt? Next thing what we are going to see is that having decided whether vessel will have plus P or minus P or plus Q minus Q, now we'll see that what are the factors which will affect that how much will be the force P value or how much will be force Q value. So that means factors affecting magnitude or the strength of force P and Q. Okay. So that factor, first one we can say, now we are listing the factors which are affecting the amount of force P and amount of force Q the vessel is going to have. First one is, of course, the heading. So heading is also playing a role as far as the magnitude of P and Q is concerned. As you can see, vessel is built in a northerly heading. This vessel is having only P and no Q. A vessel which is built on the easterly heading is only having Q and no P. Here the P is, here the P is 0 and Q is maximum. And here you can see P is maximum, but Q is 0, correct?
Yes, sir.
So now you can give a very simple answer. Let us say a ship which is built on 010 heading or 020 heading, and vessel which is built on 060 heading. Which one will have more P?
020.
Correct. Correct. So the closer the heading is towards north or south, the more P that vessel will have and less Q that vessel will have. Right. Similarly, you can see for force Q. Okay. Here, the vessel is having maximum Q, but P is 0. Okay. Here also you can see the vessel is having maximum Q and P is 0. Here you can see the Q is 0, but maximum P. So the closer the heading is towards north and south heading, the more P the vessel will have. And closer the heading of the vessel is towards east or west, the more Q the vessel will have. So if I say that if I take a heading of, let us say, 230, let us say I take a heading of 210, and another one if I take the heading of 240. So which one will have more Q?
So please repeat.
Suppose a ship which is built on 210 compared to a ship which is built on 240, which one will have more Q?
210.
240.
I'm saying which one will have more Q? 240, na? Because the
240.
closer the heading is towards east or west, the more Q the vessel will have. Right? You understood? So if the vessel is built on closer to north or south heading, the vessel will have more P and less Q. A vessel which is heading built on heading only on northerly and southerly heading, that will have maximum P and 0. The closer the heading is towards east or west, the more Q the vessel will have. On easterly and westerly heading, it will have maximum Q and the P will be 0. So amount of P and Q will depend on the heading. Second thing, the amount of P and Q will also depend on the latitude. Latitude in which ship was. Okay. Because we have seen yesterday that what is the inducing force in this we have seen it today that what is the inducing force in this, it is the inducing force is H. So it is the H which is creating the induction in this horizontal horizontal you can say plane of the vessel. So when we are talking about the H is the inducing force, so where the H is maximum, yesterday we have seen that at equator H is maximum and at poles H is 0, because H was F cos theta and value of theta at equator was 0. So cos 0 was 1, which is the maximum possible value of cos. So at equator the H is maximum, at pole the H is 0. And as we go from the equator towards the pole, what we see that H is reducing. So when the inducing force is reducing, the induction in this will also reduce. So then the amount of induction when it increases, amount of induction if it reduces, then these forces, the magnitude of these forces will also reduce. Okay. So a vessel which is built closer to the equator, where the inducing force H is maximum, will have more P and Q compared to a vessel which is built in the higher latitude. Okay. Did you get this point?
Yes, sir.
Did you get this point that a vessel built closer to the equator will have more P and Q compared to the vessel which is built in the higher latitude? Because closer to the equator, the inducing force which is causing this blue and red pole is strong. So the amount of induction or the strength of this blue and red pole will also be strong. So consequently, these forces will also be strong. So that is the second thing. Third thing, it will depend on what? It will depend on duration of build. Okay. How long the vessel was staying in the same direction. How long the vessel was staying in the same direction. So a vessel which was lying in the same direction for, let us say, 1 month compared to a vessel which was lying in for more than 1 month, that vessel which was lying in the same direction for a long period of time is likely to have little bit more P and Q because the amount of induction will be increased. Fourth point, the amount of P and Q will also depend on amount of hard iron. Amount of hard iron properties present in the ship's steel. जिस स्टील से शिप बना हुआ है उसके अंदर कितना हार्ड आयरन प्रॉपर्टीज है, so that will also affect the amount of force P and Q. And the last one is basically what we call it moderate hammering and heating. So these 3, 4, and 5, okay, they are basically, or you can say 4 and 5, they are not actually magnetic reasons. So 3, 4, and 5 are not magnetic reasons; they are the mechanical reasons. So moderate hammering and heating.
So
If
what
you are
did you say?
doing more,
0.4.
amount of hard iron properties or amount of hard iron present in the ship's steel of which the vessel is built. जो ship
Okay,
जिस steel से बना है उसके अंदर कितना hard iron है और कितना soft है. So the fifth point is moderate hammering and heating. Okay, not too much hammering and heating. So when the ship is built, that time the steel plate is hammered, okay, to make it straight, or the welding is done and the gas cutting is done. So because of that, you are doing the heating the plate. When you are heating the plate, then what you are doing? You are giving more energy, thermal energy to the electrons. So it is the electrons aligning in the same direction. That is what is the magnetism. The cluster of electrons, which are called domain, they get aligned in the same direction as the applied field. What is the applied field here is H. That is what is the magnetism. So because of the moderate hammering and heating, some of the electrons which were not having sufficient energy to align them in the direction of the inducing field, they will also get some more energy because of the heating and hammering, and they will also align in the direction of the inducing field. So there could be a increase in the amount of induction. Okay, and due to that, there could be an increase in the force P and Q due to moderate hammering and heating. So these are the 5 reasons which are affecting the magnitude of force P and force Q. Heading on with the vessel is built, latitude in which the ship was built, how long the vessel was lying in the same direction, what is the amount of hard iron present in the vessel, and moderate hammering and heating of the steel plates. Clear?
Sir, in the case of heading, you said that in northerly and southerly, the value of P will be maximum. Does the sign make it difference? Like in northerly, it is minus P, and southerly, it is plus P. So it should
Sign?
be.
No, sign is only a negative sign. You can say, see, if you see, let us say here it is minus 10. I'm just putting a value, some value as let us say P, I'm just giving you some value of minus 10, and it is plus 10. But it is the sign which is changing. So minus is only saying, that this is force acting towards stern. And here plus is only saying that force is acting towards power. So that is what is the significance of minus and plus. Understand? The magnitude is 10 only. That minus part is only telling you that whether the force is acting towards bow or stern. But the magnitude, numerical magnitude is 10 only in both the cases. Okay?
Yes, sir. Understood.
तो ऐसा नहीं है कि this plus 10 is bigger than this minus 10 because of course in the arithmetic plus 10 is definitely bigger than minus 10. No, this plus is because of the sign direction. This plus is only denoting the direction. It is not saying that इसकी value ज्यादा है. Okay.
Yes, sir.
So
Sir,
just now we
one more
are.
thing.
Yes.
Sir, in this, the induced field are coming from red to blue. So
Where?
can just,
Which?
sir, in any of the diagram, the induced this magnetism, it is coming from red to blue direction always. Like in normal magnet, it is from blue to red, right, sir?
No. What is red? Red is north. Okay, and blue is what? South. The magnetic
Yes.
lines of forces are always from red to blue. They are always from north to south.
Okay, but that is outside the magnets, right, sir? But inside
So
it is.
This is outside the magnet, na? This is outside the magnet.
Okay.
तो यहाँ पे बीच में यहाँ पे कहीं पे कंपास पड़ेगा ना, तो कंपास के ऊपर कैसे फोर्स लगेगा? ऐसे लगेगा. दिस इज आउटसाइड द मैग्नेटिज्म.
Okay, okay, sir.
So we had seen that this force Q will also cause the deviation. Let us say a vessel is having plus Q. Okay. The ship is having plus Q. So when the vessel is sailing in the northern direction, what will have? Plus Q means there is a force acting towards starboard. And what is the other force which is acting on the magnetic compass? H. H is always acting in this direction. Because of this force Q, what will happen? The resultant of this H and Q is acting in this direction. So again, this will be the deviation due to Q. So force P and force Q are causing the deviation like this. Now, when the vessel goes on a easterly heading, what will happen? Force Q is acting towards starboard, so Q is acting in this direction. In which direction H is acting? H is acting in this direction. Okay. So now H and Q don't have an angle. So here, how much this force Q will cause the deviation? 0, nil deviation. And here, let us say it is causing deviation is equal to 10 degrees east, while your magnetic compass is getting deflected towards east. If you take a heading somewhere in between, okay, this force Q, which is acting in this direction, will have a northerly component and easterly component. So this, southerly component and easterly component. So this southerly component is acting opposite to H. So this will not cause the deviation. So this component will cause the deviation. So here the deviation will be obviously less than 10 degrees because here the entire, now here only a component of Q is acting perpendicular to H. So here let us say the deviation becomes 5 degrees east. So as we go from the north towards east, what we'll see that deviation will continue to reduce due to force Q. If you take the vessel in the southerly direction and the force Q is acting towards starboard, this is the starboard. Now what will happen? This force Q is acting in the westerly direction. What deviation will cause? Will cause a, this will be westerly deviation. Now you see here you will have deviation 10 degrees. Which was a constant force acting at the, similarly the force Q, although it is a constant force acting at the compass position, but it will cause different deviation depending on what is the angle between force Q and force H. Force H fighting this force needle always pointing towards north direction. But these components, this P and Q, they are trying to deflect the magnetic compass away from the direction. Okay. So and thereby causing the deviation. So how much deviation they will cause will also depend on the heading on which the ship is sailing. That is why you have different heading, different deviation on different headings. Okay. Any doubt?
No, sir.
Okay. So now the next thing what is remaining is that force R. Whether the vessel will have plus R or minus R, it will depend on what. So we have seen that plus R means it is acting vertically downward. Minus R, that means it is acting vertically upward. So whether a ship will have plus R or minus R, it will depend on what? It will depend only and only on the hemisphere in which the ship was built. Okay. It will depend only and only on the hemisphere in which the ship is built. It will not depend on heading. Because anything which is vertical will not get affected by the heading. Because the vertical is vertical irrespective of the heading. Okay. Let us say the ship is sailing like this, and this force R is acting vertically downward like this. So whether the ship is heading in this direction or this heading in this direction, this vertical direction of the force doesn't matter, isn't it? So vertical is vertical. So vertical pay, that is not getting affected by the heading of the ship. Okay. So what is the time now? Okay, we'll continue tomorrow.
Okay, sir. Thank you.